So for this part right here, guys, this is actually a demonstration number 1 for the sweet tea. The introduction is some beverages such as tea and coffee. They might be enjoyed hot or cold, unsweetened or unsweetened. When you make sweet tea, sweetened iced tea, should you add sugar to the hot tea or the cold tea? So basically in this demonstration, we will put blue food coloring in cold water and red food coloring in hot water. Cold water for the blue and red food coloring for the hot to the beakers. You will then collect time data to determine which temperature of water will result in the sweetest sweet tea. I'm not going to show you the video first. What I'm going to do, I'm going to continue here because you have to actually complete the prediction first. Your testable question, think about this. How does the temperature of the water affect the amount of time needed to mix the liquid? So as a direction for the first part, you're going to complete the prediction by highlighting the bolded words below. So the first part is, if food coloring is added to beakers of water with different temperatures, then the hot, the cold, or neither beaker will mix first because. So what you need to do in here first, you're going to highlight one of this. Which one do you think is going to mix first? Is it the hot water, cold water, or none of them? And why do you think it? And then you're going to type your answer in this part, okay? Now, let's go back in here because then I want to show you the video. Actually, let me continue with this part. Let me think about this again. Let's do the testable question. How does the temperature of the water affect the amount of time needed to mix the liquid? Okay, so remember the variables when we were doing this at the beginning of the school year? We were talking about independent variable, dependent variable, control variables. The first part in here is the independent variable, is the cause. Dependent variable would be the effect, and the control variables stay the same throughout the whole experiment. So what do you think it would be the cause? Would it be the temperature of the water, or is it the amount of time needed to mix the water? So for the independent cause, it would be the temperature of the water. The effect will be the amount of time needed to mix the liquid. And now here, if you think about the control variables, it would be the food coloring because it's the same size of the bottles, just different colors. But then it's just food coloring, right? And then we have the two beakers. So that actually stays the same throughout the whole experiment. Now, remember, I'm going to show you this experiment. Look at this. In this part right here, you need to actually measure the data. So the time, okay, is the time it takes water to dissolve the food coloring. Think about it. The first part right here is with the cold, with the blue food coloring, and the hot with the red food coloring. And you're gonna time it. You're gonna look at this YouTube video, look at the timer at the bottom of the video, and then you're gonna go ahead and subtract the difference between the timing that you see the liquid dissolve. So let me show you the video here first. First, I'm gonna add 2 blue food coloring drops in cold water, then 2 drops of red food coloring in hot water. Now I put it probably about 12 seconds for both of them at the same time, or probably a second of difference. It doesn't matter, to be honest. But just look, which one do you think is actually dissolving first? Is it the hot water with the red food coloring or the blue one with cold water? And then you're going to measure the time. It started approximately 12, 13 seconds. And then you're going to determine after that, you're going to do it, guys, which one actually mixed or dissolved first. Was it the first hot water, the red one, or the blue food coloring cold one? And that's information that that's actually the kind of information you need for your data when you're doing this part on the recording sheet. So I'm going to keep it on for now. And now this part is 8 times as fast. And look what's going on in just seconds. Really quick. Okay? Just look in here. This is a cold water. with the blue food coloring. And now look this one with the red food coloring in hot water. Which one do you think actually dissolved first? You need the time data, okay? Now let's go back in here. Once you have the data, for example, if it's 1 minute and 20 seconds, just an example, okay? And this one is 2 minutes and 30 seconds. I don't know. This is just a guess. This is what you need to type in this part, okay? All right, let me go ahead and go back to the slides. Motion, energy level, and spacing in states of matter. This is actually a review of today's class or last Friday. I'm just recording this on Friday. Of the energy and the motion of the molecules for solid, liquid, and gas. What is the difference between the water molecules? Just look at this, guys. If you look at the solid, which I didn't mention this in class, but I want you to look at this. It has only one line, which means you see the line on top on the side for solid, only one line around the circle. That means that there's motion, but there's not. But it's they don't have the space, the necessary space to actually move around. They still moving, they're vibrating, but they're not moving freely. Now look at the particles in here for the liquid. You see that there's only two lines for each circle. That means that still they can move, right? They're vibrating more, they're moving more, they're spreading out a little bit more, they're more energetic compared to the liquid, but less than gas. Now look at the gas particles right here. They have three lines for each particle, for each molecule right there. So that means that they're moving really fast, they're highly energetic. So that's basically what you need to do for the next part. It says create a drawing that shows the motion of the water molecules, and number two, energy level and the spacing of the water molecules. So I'm going to go back to your recording sheet. You have here the blue one, which is the cold water, and the red as an example of the red coloring as a hot water, okay? So you're going to double click on each one, and you're going to go ahead and play with the circles. What do you think? Is it all together? Is it a spread around? Okay? If you want to be more creative, if you want to add the lines, you can go in here. It says, I think it's a curved one. You can just put one if you want. One if you want. There you go. Let's stop it here. Okay, you should be double click, but it's not working. It's not letting me go now. Anyway, you get the idea. You can actually play around with this. Don't do it with this part. Oh, I hate it. Anyway, I don't have time to record this again. So just make sure you can play with the drawing. I don't know, use different features. You have the time to play with this later. So you might be actually get better than me. Let me go back to this. I don't know why she has this one. Okay. So play with this. Each one. Why are you doing this, computer? All right. I don't know why. Let me go ahead and save this. Just make sure to do this for both of them, okay? For the blue one and the red one. This is actually what you need to do for the sweet tea demonstration number one. That's it. Okay? So hang in there, guys. I'm going to go ahead and record now for the second demonstration. And take your time to do this exercise. Try to comprehend what we're doing right now. And I'll see you shortly.